So in order to find the volume of this solid, what we're going to do is we're going to find the volume as if there was no void in here. Okay, there's no void in here. So if there's no void in here, what would be the top function, and then what would be the center function of this solid?
Do you mean void
like this empty space right in here? So let's ignore the empty space. Let's pretend that all of this was blue. This is just all one big solid. It kind of looks like a cylinder with this weird little bow thing in it. Okay, I don't know if you would call that. I don't know what looks like that. I don't know. Okay, so let's find the volume of the whole solid as if there was no hole in it.
Reverse donut.
And so what you're gonna do is first of all recognize the cross section. The cross section is a disc. Right now it looks like there's a hole in this disc, but we're ignoring that. We're saying that it's solid. And so what we're going to need to do is first we find the area function of that. Man, I got to change the thickness of that guy. He's like bugging me. Okay, so we have A of N. So this is the area of the cross section. So if the area of the cross section is pi n squared. Hey, is it always pi n squared when we're doing volumes by revolution? Yes, it is. Okay, I guess the hardest part would be to find the n function. So my n function is going to be a function of x because we're perpendicular to the x-axis. So it would be pi times. No, I'm sorry, not pi times. What would the radius be of our discs? So this is the center. This would be the disc right here. What's the radius? How would we find that?
With the top function.
With the top function and
minus the
0.1 times x squared plus 2.
yeah, minus the center. What is the axis of revolution here? It looks like it's negative 2.5. So this is y equals negative 2.5. That's my volume or axis of revolution. Okay, so to find n, I go top function, which is this weird thing. It goes 0.1 times x squared plus 2. And we're going to subtract from that negative 2.5, which would actually be adding it. So that's how we find n. That is our radius. So now I can write the area function in terms of x by plugging the n into it. So I have pi, and then I have something squared, and that something squared is, actually I can do that, huh? Let's go 2 plus 2.5, that'd be 4.5. So you have 0.1 x squared plus 4.5. So now we take our area function and multiply it by the height and add them all together. The height is going to be our integral. So let's put our area function in there. It would be a of x dx. What is our integral right now? We're going from what to what? A is negative 2. B is 3. So I'm going to go from negative 2 to 3, which would look like negative 2 to 3. And then we'll have pi. We could put the pi on the outside because he's a scalar. Yeah, go ahead.
Why are you multiplying by the height?
Because I'm trying to find volume. Whenever you try to find volume, you find the area of the base and multiply it times the height. Our base in this case is a disc. Now it has a hole in it, but like I said before, we're ignoring that hole right now. This right now would find the volume of the whole thing if we didn't have a hole. So if we want to find the volume of just what's actually there and take out the hole, we have to now find the volume of this weird inside shape. That weird inside shape looks like, I don't know, a vase? Like what looks like this?
Yeah.
Okay, so here's our inside shape. Now we got to find the volume of that so we can take it out. So let's first find our area function. So now I'm going to do a new area function. It's still pi n squared because there's still discs. Where are my discs? The disc would be going up to here. I don't know. Can you see that? It's black. It's really hard to see. I don't know. Let's see. Students crack me up sometimes. Okay, so here's your disc on the inside. Now, how do I find the n of these discs? I have two different functions now. Well, one different function. It's n of x. We're going to go this outer function minus the inner function. The inner function is just a line. It's because it's an axis of revolution.
Sine x minus 1 minus 2.
Yeah. So sine x minus 1 minus negative 2.5. And we could, we can add that 2.5 to the negative 1 to simplify it a little bit. So it'll be sine x plus 1.5. So that's our n. So now we can plug this n into the area function and then do our integral at the same time. So we're from negative 2 to 3. And then we have pi, what's the n again? Sine x plus 1.5 squared dx. So what did we just find right here?
The vase.
That's the volume of this vase-looking thing. So if we want to find the volume of the actual solid that we're seeing, we got to take the actual solid that we're seeing and subtract the inside. And then that's your answer. So I'm gonna clean this up by writing it as 1. It's gonna be from negative 2 to 3, and then I'm gonna put the pi out here outside. So I'm taking the scalar out of this one and the scalar out of this one at the same time. That's that guy right there. That's that pi. And then we're gonna subtract. So we have 0.1 x squared plus 4.5 subtract sine x plus 1.5. Oh, these are squared, aren't they? Yeah, they're squared. And then I have dx. See, normally like the pi would be here and the pi would be here, but I took those guys out and I put them out in front. All right, and so if you plug this in, you'll find the volume of just the solid on the outside. That'll give you your answer. Sure, when you guys plug this into your calculator, you guys have an extra set of parentheses like that. So everything that's inside the integral should get parentheses. So start it out by saying pi times and then do math 9 to get your integral. This is for a Texas Instrument. Casio's a little different. So before rotating it, this is what it looks like. Your answer, what was it, 303 point what? 382? Cubic units. So, I mean, like, on your paper, it's not going to show you guys a nice solid. This is all it's going to give you. It's going to tell you the upper function, it's going to tell you the lower function, and you're going to have the axis of revolution. And that's all the stuff that you need, along with the integral, which is from negative 2 to 3, for your solid that's formed. So sometimes questions will say something like, what is the volume of the solid formed by rotating this function f, and function g, or rotating the area between function f and function g around the axis of revolution of negative 2.5. That would be the question for a problem like this.